this video, I want to walk you through quickly just the structure of a repeated measures ANOVA. So in this introduction to statistics class, we're not going to go through conducting repeated measures ANOVA in JASP. The bigger thing I'd like you to get is that you get how get repeated measures ANOVA conceptually. So here's the example of how repeated measures ANOVA it's broken up. So we've got a total variance, all the variability that exists within the study. And we partition that out to between treatments variability and within treatments variability. So if we stopped right here, we're at a one-way ANOVA, if you remember that. What's different about a repeated measures ANOVA is getting more than one measure on an individual. And so in the within treatments variability, we can start controlling for certain subject variables, and that's called the between subjects variability. And we would subtract that out of this within treatments variability, and what we'd have left over is the error variance. Basically, it allows us to get a more accurate sense as to what's taking place within a particular study. So here's an example. Researchers examine the effect of different distractions on driver error, and we've got four treatment conditions here: talking on a handheld cell phone, talking with a hands-free cell phone, eating, or a control condition with no distraction. So these two, the eating and the control condition, are kind of our two control conditions. This one is more of an empty control group, and this is a comparative one to the hands-free cell phone and to the talking. Each subject drove through the course in each condition as we go through this, and a proper design would say some might go in this order as we have here, but Bob might start with the hands-free and then go to eating and then to the handheld and control. Kathy might start at the control and so forth. The idea is counterbalancing that might take place, that should take place. So below is the data from the study, and what I'm saying here and what you're going to have to do in your homework is to draw an arrow to the parts of the table that are related to each of the variance partitions above. So the first one, the total variance, that's just everything within the particular study. So that's just all of this. And this might signify it as well, the sum of all the x squared. That's our total variance that we have here. Our between treatments variability, that's our mean differences that we have between the groups, between the treatments. So in that way, that's just like in the one-way ANOVA, what we saw in that. The within treatments variability here, that's the variability that exists within this handheld group by the different subjects. And that's also summarized up here, summarized by the sum of squares for the handheld group, okay? And so same thing for the hands-free, okay? That's summarized by the sum of squares here and so forth. So in this example, the control condition had the least variability within its group, whereas the eating condition had the most variability within its group. And then the between subjects. So the between subjects is what we call these person totals here. So you'll notice as Ava drove, she made 3 errors in this condition, 3 in the hands-free condition, 4 in the eating, and 1 in the control condition. That adds up to be 11 errors total. Whereas Evan, you'll see, Evan's probably somebody you don't want to drive with no matter what. Even almost in the control condition, there's still a lot of errors that end up taking place. You add those up to be 32. So this right here is the area for the between subjects variability. And that's what we would subtract out of this, and what we'd have left is the error variance. And that's what in this particular study, the repeated measures ANOVA, we divide the mean square for the between treatments divided by the error variance, and that's what would give us our F value in this particular study. So again, I just wanted to quickly go through this for you conceptually to make sure that you're understanding what's going on in a repeated measures ANOVA.